So let us see the condition monitoring now. So we know that condition monitoring is the backbone of condition-based maintenance, because you have to monitor to know the condition of the equipment before you carry out maintenance. It's just like humans physically, okay? So there are certain parameters in humans that you can monitor to give you an idea as to the condition of that human or that person. One of them is temperature, okay? Remember that the normal body temperature is 37 degrees Celsius. So that is what is normal. Equipment too, in the process plant, they have their normal operating temperature. So anything above that 37 in humans is an indication that there is something wrong. Okay? Anything below 37 also is an indication that something is wrong. So monitoring the temperature of the human body can give us an idea as to the condition of the human body. Okay, that's why when you visit the hospital, one of the first things they monitor, apart from your blood pressure, is temperature. Okay, so all of this will give an indication as to the wellness of that person. So it is with plant equipment too. Plant equipment, they have normal operating temperature. There are other parameters too, and you can look even pressure. You know, a human, so we have normal pressure. Okay, so this will give us an indication as to the health or wellness of the plant equipment. So that is what we are doing in condition monitoring. We look at a particular parameter that will give us an idea as to the condition of a particular component in the equipment. Okay, so we have what is normal to the operations of that equipment or to that process. So anything outside that window of normality becomes an abnormal condition that we need some intervention, or we now become a source of concern that we need to investigate to know clearly what is actually causing that variation from what is normal. Okay, so that is in essence what equipment condition monitoring is. We monitor the condition, monitor a particular parameter to give us the condition of the equipment. So we are going to look at it, the equipment condition. So now let's take that pumping system for example. Remember, we have the electric motor, we have the pump. Okay, remember we have bearings here, we have bearings here, we have impeller here. Okay, remember we can look at the discharge pressure, the suction pressure. Okay, all of these are indications of certain things. If the suction pressure is low, that is an indication that where the fluid is coming from is either getting low. Are we getting it? It's either getting low or there are some constraints in the lines. So you see that it is worth monitoring the suction pressure. Then the discharge pressure. So as you go out to take your bearing temperature, you record, you log. Okay. Then as you are logging, you see that if everything is normal, you have that normal temperature over time. But as the equipment starts deteriorating, you see that the bearing temperature will start going up. Once the bearing starts deteriorating, the temperature will start going up. Even the vibration you are monitoring, you see that the vibration will start going up, which means that the probability of failure is already increasing. Are we getting it? So that parameter that you are looking at will not tell you that something heinous, something dangerous is happening within that component. which means you need to do something to bring that condition back to normal. Are you getting the analogy? Yes, so that is what we do in condition monitoring. So here, like we said before, as you go out, you take your readings of that particular parameter, be it temperature, vibration, or even pressure. Okay, so as you are logging, then as it is increasing, you'll be seeing it. Okay, so this will now give you a visual representation of what is actually happening, or as that condition is deteriorating within the component. Are you getting it? So at this stage, we have the level that is tolerable, that is always recommended by the manufacturer. Or from experience in our own facility, we know if the temperature goes beyond this level, it can cause the failure of that component or of that equipment. Okay? Or if the vibration goes beyond this level, that is what informs the trip point setting. Okay, so before it goes beyond the level, it will trip on high vibration or high temperature. Are we getting it? Okay, so which means you will now see it when you monitor that condition or that parameter, and then that will now inform the kind of maintenance strategy that you will do. So if you are taking it on the bearing housing, assuming you are taking it here, okay, you know it is this front end bearing of the electric motor that you'll be changing. If it is this bearing here, of course, you know it's this bearing you'll be changing. If it is the one here, you know it's this bearing that you will also changing. Are we getting it? So if, as we'll see later, if the vibration analysis tells you that the impeller, coupled with other parameters that you look, maybe flow rate or discharge pressure, okay, even suction pressure, because once the impeller is wearing out, it will not create that level of suction that is needed to pull the fluid. Are we getting it? From wherever the reservoir is or wherever it is stored. So all of this will affect the operations. So we'll be seeing them on that parameter that we are monitoring, and then that will inform us whether we should carry out maintenance intervention to restore the equipment or the component back to functional status. Okay. So this is also the monitoring of a particular parameter. Okay. So as it is deteriorating, you'll be seeing there. So this is called trending. You trend that particular parameter over time. So as you trend that particular parameter, you see it as it is changing from what is normal, okay, until it gets to where you can no longer tolerate, or where your process can no longer tolerate, then you intervene, okay, to bring it back to functional status. So we are going to look at the various types of condition monitoring that we have, and which components of our plant, process, equipment, or facility that such condition monitoring technology can be deployed. Okay, so we have different methods of monitoring the condition of our equipment, ranging from physical, visual inspection and what have you, to the one that will require us to deploy simple and then to complex monitoring equipment that will involve complex analysis. Okay, data gathering. As you gather those data, then you analyze those data to glean some information that will give you an idea as to the condition of those equipment. So you gather those data over time, okay, and then that will help you to appreciate how your equipment functions. So such that when you see such trend in the future, you don't need to go far in analyzing what is happening. You know precisely that this trend, you've seen it before, and this is what can cause this trend. Okay? So as simple as touching your bearing housing is a form of condition monitoring. As simple as listening to the sound of your equipment as you are going through your plant, okay, is a form of condition monitoring. As simply as looking at the flame from your burners, okay, there are forms of condition monitoring. As simple as looking at the exhaust gases, the fumes from the exhaust, either of your reciprocating engine, your gas turbine, all of those, they give you an idea as to the condition of the equipment. Okay, so we are going to look at some of them, as you can see on the screen. So it ranges from visual inspection to the one that will involve us to use technology. Okay, so the visual or physical inspection has limitations actually. Know that before we can see visibly or use any of our senses to sense changes in the condition of our equipment, it means that the deterioration would have gone so far. Okay, and in most cases it's already entering the wear out period before we can sense them. Okay, which is this area, before we can use any of our physical senses to actually sense them. But if we have technology in place, we will see that at the incipient stage, when it is starting, okay, we will see that changes, and that will help us to do things that will stem that condition, okay, from deteriorating. So we are going to see some of them, as you can see on your screen. Like on motor now, we can do motor current analysis. Okay, so you know that the current that is flowing through your motor windings or even your generator windings will influence the strength of the magnetic field. Are we getting it? So as that field is changing, that will give us an indication of the amount of current that is flowing through. Okay? With that, we can monitor the condition of the equipment as to the amount of load that we have on the equipment, the voltage surge, okay, that we have on the equipment, even the speed. Okay, we know that the rate of change of that magnetic flux affects the speed also. So all of those will give us so many information about the electric motor. Then we have the loop oil analysis. Wherever we have loop oil, remember the loop oil its function is to lubricate all rotating parts, to reduce the friction between rotating parts. But even at that, even with the presence of that lubricating oil, wear still takes place. Okay, so when we take sample of this oil, analyze, and look at the level of wear particles, that will give us an indication as to the condition of the equipment itself. Okay, and we can even analyze to the extent of knowing which component, which particular parts of the equipment is wearing. Are we getting it? Then we have thermography, which has to do with the heat energy that is emitted from the equipment. So as we'll see later, when we can when we look at this heat energy, okay, if we convert that heat energy to something that is we can really understand, that is, convert that heat energy to, we call it thermogram. infrared thermography. Okay, so we will see that looking at this heat energy will give us an indication of what is happening. We'll also look at that later. Then also vibration, okay, especially around bearing houses. All of this gives us an indication of what is happening later within the equipment. So even performance monitoring, the discharge rate, the flow rate, I will get the volume of production. Okay, all of those, they are indication as to the health of the process and equipment. So we are going to look at these condition monitoring strategies later, okay, or technologies that we can use to look at the condition of the equipment and the particular component that we can monitor with the various condition monitoring strategies or technologies. Okay, so what are the key benefits of condition monitoring? We have outlined many before, okay, but we are going to see some now, which is one, early detection of fraud, as we have said before. So if the equipment is subjected to stringent operating conditions, even in the first week of operations, you will see that that condition that you are monitoring, okay, can go into this wear out region. And once you see it going into this wear out region, you know that that component is deteriorating already. Are we getting it? So it helps you to see that fault condition at the incipient stage, when it is in the formation stage, before it affects other components in the system, okay, allowing us to continue monitoring or to intervene to bring it back to what is normal. Then it also helps us to plan and optimize our preventive maintenance program. So a reliability-based maintenance program, what you do at the end of the day is to have the right maintenance mix of all of those 4 maintenance strategies that we discussed earlier. Okay, there are some components of the equipment that you know have little effect on the operations of that equipment or of the process, or whose cost of replacement is minimal. This effect is minimal, does not affect the safety of your process or of your plant. Okay, you can allow such equipment to run to failure. There are some that you cannot allow to run to failure. The preventive maintenance program, which is time-based, to be the most feasible. Either it is cheaper or you have the in-house technology and capability to do such, or it will be less expensive for you cost-wise. Okay, then you can also have the condition monitoring technology. Okay, there are some critical components and equipment that you cannot allow to fail without you knowing, because if they fail, the results will be too catastrophic to your operations, either cost-wise or can affect the safety of your plant. Are we getting it? So such components, you need to deploy condition monitoring technology or strategies in place so that before it ever happens, you will know. Okay? So you see that condition monitoring will help us to optimize our PM program, then and eventually to increase the reliability of our facility. Okay, which is one of the major aims of deploying condition monitoring in our system. Of course, to extend the life of our equipment. Okay, that is, push this wear out period to the front. Okay, thereby helping us to extend the life of the equipment, and of course improve the efficiency of our plants and processes. So, which area do you think we can apply condition monitoring? Condition monitoring is a very versatile program that have or technology or maintenance strategy, let me put it like that, that have a very wide range of application. Okay, because there are so many conditions that you can look at on various equipment that will give you the wellness or the health status of that equipment. So we'll look at some of the companies. So in manufacturing and industrial equipment, we can apply condition monitoring. Okay, so which area or which plant equipment do you think we can apply condition monitoring in the manufacturing sector? You can apply it on rotating equipment. And that will give us an idea as to what is happening within those equipment. If you take pump, compressors, turbines, for example, okay, you will have a good idea when you deploy technology like vibration on them, even oil analysis, and even the infrared thermography. Okay, that will help to know the condition of such rotating equipment. So most of these condition monitoring equipment technology, they are heavily deployed on rotating equipment, though we can still use them on static equipment like the infrared thermography. Okay, can assist us to look at both rotating and static equipment and even our process. Okay, then bearings, as we have outlined before. Anywhere that has bearing, you can use any of these condition monitoring technology. Gearboxes, okay. Gearbox is one of the effective condition monitoring technology you can use. Is oil analysis. Okay. Then after oil analysis, you have the vibration monitoring and analysis. Okay. So all of this can give you an indication as to what is happening within those gearboxes. Are we getting it? Then the electric motors, as we have discussed earlier, looking at the winding condition, bearing conditions, and what have you. Okay? So condition monitoring can be deployed there. Even on the conveyors. And we can use infrared thermography to look at these conveyors to see the conditions of these conveyors, ranging from where we have the rollers to the bearings and even on the conveyor belts itself. Are we getting it? So all of these are areas we can. Then electrical equipment, infrared thermography, the ultrasonic, ultrasonic technology or ultrasound. Okay, we can use it to detect things like corona, arcing. Okay, infrared technology, as we'll see later, can also be used to detect when certain things are happening within the electrical system. So all of those we will see later. Then condition monitoring can be applied in power generation. Okay, power generating stations. So we can use it to look at the turbines. Okay, the turbines vibration will give us an idea as to what is happening within the turbine. Oil analysis. Okay, then like in this gas turbine now, okay, you see that we can look at the flue gas condition to give us an idea of what is happening within the turbine and the compressor itself. So as you can see here, okay, so this is the compressor. So the compressor discharge temperature and pressure. If we monitor that, that will give us the condition, idea as to the condition of the compressor itself. Are we getting it? Since the discharge temperature and pressure will affect what is happening within the combustor. Okay, then Vibration analysis too can give us an idea as to what is happening within the compressor and the turbine itself. We can also use infrared thermography to look at the blades, okay, of the compressor and of the turbine itself. So we can see the theoretic conditions as they are developing. Even monitoring the flue gas temperature will give us an idea of the efficiency of the turbine itself. If enough energy, okay, is extracted from the combustion product that is coming from the combustor at this stage, as you can see. Okay, so you'll see that there are a lot of parameters we can look at to look at the condition of the turbine. Okay, so this is the blade. Like we said, we can look at the vibration, we can look at the infrared thermography, can also give us an idea. Okay, then the generator itself, we can look at the winding temperature. Then, bigger generators will need effective cooling. Okay, the delta T between the inlet coolant and the outlet coolant, okay, will give us an idea as to the effectiveness of the cooling. Are we getting it? So if the temperature is also increasing, what that is the winding is increasing beyond what is normal, we also know. Infrared thermography too can be used. Then vibration analysis can also be deployed on the generator. So as we will explain all of these technologies later, we will see how these could effectively be applied on various equipment. Then on transformers, infrared thermography is one. Then we can also look at the winding temperature, okay, to give us indication as to the winding conditions. Then we can do oil analysis, dissolved gas analysis to know what is actually happening within those windings. Okay, all of those can give us an idea of what is happening within the transformer. So we can also deploy condition monitoring on transformers and even switch gears. Okay, within the switch gears we have conductors, we have breakers, we have current carrying components. As we'll see later, we'll go into infrared thermography. So condition monitoring technology or strategy like infrared thermography will help us to see the condition of the components of the switch jar. Then ultrasonic technology that will help us to know if we have a corona, okay, or arcing events within all of these switch jars. Okay. All of these are some of the condition monitoring technologies that we can use. Then, like we said earlier, is a very versatile technology. We can apply it virtually anywhere. Okay? Then we can also apply it in the oil and gas industries. You can use it to look at the pipeline, the pipeline's integrity, pipe thickness. Okay? There are technologies that will assist us. The ultrasonic is one, thickness gauging is another. The infrared thermography can also assist us in some instances. Okay, especially areas where the fatigue could be established. Then pumping stations, okay, on the pump, the electric motor, and what have you. There are static equipment like these heat exchangers, as you can see here. So we can use parameters like inlet and outlet temperatures to know the condition of the heat exchangers. Are we getting it? Then we can use pressure too, inlet and discharge pressure, to also give us an idea as to what is happening within. Then we can also monitor, the In the heat exchanger, two fluids, they are actually allowed to transfer heat between themselves, okay, without the component coming in contact, without these fluids coming in contact with each other. So by monitoring the presence of one in another will help us to know the condition of the heat exchanger component or fluid or tubes, I need to say. Okay? So all of these are some of the condition monitoring technologies that we can use. Like we said, pumping stations, vibration analysis, pressure, temperature, infrared thermography, all of these are some of the parameters that we can look at to know the condition of our equipment. Then on offshore platforms, which is a summary of all that we have explained before, we can use all of those technologies. Then rotating equipment, okay, like we said before, it's one of the areas where we apply vibration analysis, okay, oil analysis, so that as the condition of the equipment is deteriorating, we will see them before it deteriorates to failure stage. Static equipment, like we explained before, okay, your heat exchangers, your heaters, your boilers, okay, so we can use technologies like infrared to look at those heat exchangers, to look at those boilers, to look at those heaters, okay, to look at the heat exchangers that are the boilers. Are we getting it? Even to look at the flue gases. All of this will give us an indication as to what is happening within the equipment, okay.